Today we're looking at notes 511, systems of linear and quadratic equations. So remember, when you're finding a solution to a system of equations, that means you're finding where the graphs intersect. So what we're going to be looking at here is both quadratic and linear equations. So if I ask you to solve this equation, this system of equations, hopefully you're thinking in your brain, well, it's a quadratic in a line. So in this particular quadratic is downward facing. There are a couple of possibilities for how they could intersect. So it could be that the line maybe is somewhere up here and they don't ever intersect. It could be that the line just crosses at one exact point. It also could be that the line cuts through at 2 points of this quadratic. So we've got 3 possibilities. Either they intersect none, never. Either they intersect once at one little point, or they intersect twice at 2 locations. So what we're going to do, the easiest way, if they're both in y equals, the easiest way algebraically to solve this is quote-unquote substitution. These are both y equals, so I can set them both equal to each other. So that would mean I would have negative x squared plus 5x plus 6 equals x plus 6. And then I go ahead and start solving. So to get everything on one side of the equal sign, I'm going to subtract the x and I'm going to subtract the 6. So minus x here, minus 6 here. So this will become negative x squared plus 4x, that actually cancels, equals, and then obviously those canceled, that's why we did that on purpose. So now I've got this wonderful equation here that's really easy to solve because I see they have a GCF of x. Now remember, technically you should take out that lead negative as well, so we're going to take out the negative x. This will become x, and this will become minus 4 equals 0, set each factor equal to 0 and solve. So negative x equals 0, x minus 4 equals 0, solve each. So on this one, x equals 0, on this one, x equals 4. So I have 2 x values for solutions. So remember, again, a solution to a system of equations is where they intersect. It's a coordinate on the coordinate grid. This just gave me 2 x values. I would also then need the y values that go with each x value. So that means I need to plug in each of these x values into one of the 2 equations. Doesn't matter which, so you could probably guess which one I'm going to pick. I'm going to pick this easy one. So if I plug in 0 here for x, I get y equals 0 plus 6, so I get y equals 6. So my first coordinate of intersection is 0, 6. If I plug in 4 here into this one, y equals 4 plus 6, that's going to give me y equals 10. So my next coordinate of intersection is 4, 10. So then I've got my 2 coordinates. This line must do something like this and cross through twice. Here's what I want you to write down next. I want you to write down steps for checking in calc. Okay, so obviously your first step is going to be to plug each equation into y equals. Plug in each equation into the y equals of the calculator. So I've already cleared my calculator. I'm going to put in the negative x squared plus 5x plus 6, and then I'm going to put in the x plus 6. Okay, so I've done that. I've plugged in each equation into the y equals. 2, you're going to look at graph and adjust window if necessary. Okay, so hopefully you all know how to get to the graph in the calculator. So look at the graph. So just hit this graph button here. All right, so looking at the graph. So just as we suspected, 2 spots of intersection. So adjust window if necessary. Y'all, this point here, it kind of goes off the screen, so I'm going to adjust the window. So how do you do that? Well, with this window button. So the window tells me how high and how left and right the graph goes, the screen. X min, X max, that means how far left, how far right. Okay, and the scale is by 1 unit. Y min, Y max, that means how far low, how far high, okay, Y, and the scale is by 1. So I'm not concerned about anything else but the fact that the top of the graph was kind of going off a little. So I want to adjust the Y max. I want it to go high, higher than 10. So let's make it 15, okay? I don't think it was off by a whole bunch. And let's look at it now. So yeah, now my graph is clearly on the screen. And so here's what you're going to do. After that, your buttons are second, we've done this before, second trace. So let's do it. Second trace, which is the calculate button here. And you should know 5 because we want the intersection. Second trace 5 for intersect. Okay, so number 5. And then you're going to, step 4, you're going to hover over the intersection. So where the two graphs intersect, and then you're going to hit enter 3 times. Enter times 3. Okay, so my cursor is actually hovering over that intersection right there, so I don't need to move it. I'm just going to hit enter, enter, enter. Intersection 0, 6. Well, looky there, one of our coordinates, 0, 6. So let's do it all over again because on this graph we had 2 intersection points. So second trace 5. Now I need to move that cursor to the right until it gets to that next intersection point over here. That's good enough. Hit enter 3 times. 1, 2, 3. There we go. 4, 10. There you go. So that just checked my second answer there. All right, so now you've got the steps. Let's do another problem. So looking at the second problem, hello. It would help if I put the y equals first. Y equals negative x squared minus 2x plus 8, and y equals x squared minus 8x minus 12. Okay, again, to solve this, the easiest way algebraically is going to be substitution, setting them equal to each other. So negative x squared minus 2x plus 8 equals x squared minus 8x minus 12. Okay, because that's a negative x squared, and I really don't like working with negatives, instead of getting 0 on the right, I'm going to get 0 on the left. So I'm going to move everything over here, over there. Okay, and that's allowed as long as I have an equal sign. Remember, we're not dealing with inequalities today, we're dealing with equals. So I'm going to add x squared, add 2x, and subtract 8 because I'm trying to get rid of all this stuff over here. So that means I'm going to add x squared to this side, add 2x to this side, subtract 8 to this side. Okay, what you do to one side, you got to do to the other. All these cancel out. I did that on purpose. Okay, so 2x squared minus 6x minus 20. This looks like it might end up being a nice problem to factor. So let's try that first. GCF of 2, x squared minus 3x minus 10. So are there two numbers that multiply to negative 10 but add to negative 3? So negative 5, x. And 2, would that work out? Is negative 5, that's negative 10. That adds to negative 3. We're good to go. So set each factor, x minus 5 equal to 0, x plus 2 equal to 0. So that means x equals 5 and x equals negative 2. So I've got my two solutions, but I've only got their x values. So I need to go back and plug this in here to get my y values. Here's the deal. Y'all, these are both quadratic, okay? I look at this and I look at this and I say, okay, no way do I want to work with a negative because that's going to be a pain. So I'm going to plug my x's into the second equation. So I would have y equals 5 squared minus 8 times 5 minus 12. That's my first one. My second one's going to be y equals negative 2 squared minus 8 times negative 2 minus 12, and I'm going to solve each. So on this one I get y equals 25 minus 40 minus 12. Okay, So here on this one, I get y equals negative 27. Is that right? Negative 52. Okay, and then on this one, I get y equals 4. That turns to a plus 16 and a minus 12. So that's 20 minus 12, so that's going to give me 8. Okay, so my two coordinates are 5, that was my x value here, negative 27, and then my x value here was negative 2, comma 8. So we would definitely want to go back in our calculator and check both of these. So because that solution is a negative 27, you know you're definitely going to have to adjust your window. So when you get to class tomorrow, play with it. Try and play with the window and check it with your calculator if you don't have one at home.